Hey guys, what's up? Here with day 26. Just a quick video here. I want to do one more example of a second derivative implicitly. And then I wanted to prove to you the those arctan, arcsine, arccos derivatives. So here we have it. Here's our problem. Here's our problem. We're looking at 4x cubed plus 5y squared equals 17. We want to find the second derivative in terms of x and y. So we looked at that yesterday in terms of x and y, meaning that we're going to have to sub out our dy dx. So in order to find the second derivative, we need to find the first derivative. So go ahead and do the first derivative, solve for dy dx. Pause it here, do that, reduce it, and see what we get. All right, when we do that, we should get a simplified answer of negative 6x squared over 5y. Again, I always like to circle my dy dx because I know I'm going to have to sub it out here in a little bit. Okay, so now I need to go on and do my second derivative. I'm just going to derive both sides of the equal sign. The derivative of dy dx is the second derivative. So the derivative on the right side of the equation, I'm going to have to use a quotient rule here. So I'm going to do the derivative of the top times the bottom minus the top function times the derivative of the bottom. Note when you do the derivative with respect to y, you need to tack on dy dx, all divided by y squared. Also note that that is the quantity 5y squared. I'm going to do just a little bit of simplification here before I sub in my dy dx. I'm just going to clean that up a little bit. Negative 12x times 5y is negative 60xy. Negative 6x squared times 5 dy dx is negative 30x squared, but I'm subtracting that, so it ends up being plus 30x squared. Dy dx over the quantity 5y squared is 25y squared. All right, now this is the second derivative, but it's not in terms of x and y. It's in terms of x and y and dy dx. So I want to sub out that dy dx with what I got up here. So let's go ahead and sub that in. Now, my answer is in terms of x and y. On a free response, I would circle this and leave it. That's correct. But on multiple choice, we'd have to simplify it down. let's see what happens when we simplify this thing down a little bit. A couple things I notice here. When I multiply 30 times negative 6 over 5, I'm going to change these both divided by 5. 30 divided by 5 is 1. 5 divided by 5 is 1. 30 divided by 5 is 6. So I'm going to end up with this. My overall sign on that second term now is negative. 6 times negative 6 makes negative 36. X squared times x squared is x to the 4th. That's still over y. And the last thing I would do is go through and multiply all of the terms here by y to get rid of that fraction within a fraction. And we get this. All right, and we can check to see if it simplifies at all. It's not looking like it to me. So we can leave it just like that. Good. I just wanted to show you, here's what we know. When we do the derivative of arc sine of x, we get an answer we just memorized as 1 over 1 minus x squared. And that 1 minus x squared is under a square root. Well, I'm going to prove that to you now using implicit differentiation. So remember this answer. And let's see if we can get that using implicit differentiation. The first step I'm going to do here is I'm going to take the sine of both sides of the equation. So I'm just going to turn this into sine y equals the sine of the arcsine of x. Well, this just comes out to sine y equals x. The sine of the arcsine of x just simply equals x. So y equals arcsine x is the same as sine y equals x. Now let's do the derivative using implicit differentiation. Here's what we get. We get cosine y dy dx equals 1, right? Whenever I do the derivative of y, I needed to tack on dy dx. The derivative of x is simply 1. Now I'm going to solve for dy dx, and I'm going to get dy dx equals 1 over cosine y. Now that does not look like our answer of 1 over the square root of 1 minus x squared. But that's okay, because that dy dx is in terms of y, the other one was in terms of x. But let's see if we can prove that 1 over cos y here is the same as what we saw up here, 1 over root 1 minus x squared. Well, to do this, we're going to use what's called a reference triangle. Now, I'm not going to make you do this in class. I just think it's kind of an interesting way to solve a problem. So look at this statement. It says sine of y equals x. Let's use a reference triangle. We're going to call that angle y. Remember, sine means opposite over hypotenuse. So think of this x as x over 1. That means the opposite side must be x, and the hypotenuse must be 1. So what is that missing third side? Well, if you do the Pythagorean Theorem, all right, let's just call it A for now. we've got x squared plus a squared equals 1 squared. Well, a would end up being, a squared would equal 1 squared minus x squared. And a would then be the square root of 1 minus x squared. So this missing side here, instead of calling it a, I'm going to call it the square root of 1 minus x squared. And I can think only in terms of the positive there, the positive square root, because we're talking about the side length of a triangle. Okay, so now let's think about this. What could we replace cos y with? Well, cosine is adjacent over hypotenuse. So from y, here is the adjacent, here is the hypotenuse. So it's root 1 minus x squared over 1, or simply 1 over the square root of 1 minus x squared, which is exactly what we got up here. I don't know about you guys. I thought that was kind of cool the first time I saw it. If you want, go ahead and try it with arc cosine and arc tangent and see if you can derive those formulas as well. All right. Thanks for watching. Have a great day. 2 chains.